In this lecture, we will mainly focus on the property of Z transform, which is known as the convolution property. So very important property. You need to give some importance for this particular property because the analysis of a LTI system, uh, analysis of discrete time LTI system is mainly based on this Z transform. Okay, and also to find the transfer function, we are using this property convolution property of Z transform. And in this property you can see that if the transform of x1 of n is x1 of z and the ROC is r1, and another signal x2 of n whose transform is represented by x2 of z, and the ROC is represented by r2. Now we can see that the convolution of two sequence x1 of n convolution x2 of n, this is not multiplication, it's a convolution operation, and in time domain the convolution operation becomes multiplication in frequency domain or in Z domain. Here you can see that it's simply x1 of Z into x2 of Z. Actually the convolution operation is defined as like this, a convolution of two sequence. I can write k is equal to minus infinity to infinity x1 of k into x2 of n minus k. Okay, this is the convolution operation. You can expand this convolution equation, x1 of n convolution x2 of n can be written as sigma k is equal to minus infinity to infinity x1 of k into x2 of n minus k. So in place of this complex equation I can use the symbol multiplication if it is in the Z domain. So that's all about the convolution property, and the ROC of this two signal becomes intersection of R1 and R2. Okay, we will see how we can do the problems based on this particular property. So in this question you can see that you need to find the Z transform of x of n, where x of n is given by u of n minus 2 convolution 2 by 3 whole raised to n into u of n. So there are two signals. This one signal is you can write this is, you can consider as x1 of n, and the second signal is x2 of n. Okay, we got two signal and the convolution of two signals. So instead of using direct formula we can use the convolution property here. Okay, for example the first signal, instead of writing x1 of n I will write u of n. Okay, if the signal is u of n step signal, okay, based on this particular property, okay, a raised to n u of n, the Z transform is Z by Z minus a. This is standard result. In this case here a is equal to 1, so simply u of n, so you can write Z by Z minus a, and the ROC is modulus of Z greater than 1. From the previous lecture we already got this particular result, so I can directly write the result. So I can write it becomes Z by Z minus 1, and the ROC is modulus of Z greater than 1. And now the signal x1 of n, it's simply the shifted version of u of n. Okay, so if it is a shifted version of the signal, there is the time shifting property. So time shifting property, if a signal x is shifted by n0 unit, then the transform is simply multiplication of Z raised to minus n0. Okay, so based on that I can write here in place of n0 it is 2, so we can write Z raised to minus 2 in the transform of the original signal. So transform of the original signal is Z by Z minus 1, so we can write it becomes simply Z by Z minus 1, and the initial signal ROC is you can see that this is 1, and modulus of Z 1 means greater than 1 means like this. Now we can see that there is another term, okay, it is Z minus 2, so there is another term Z minus 2, and this equation becomes infinity when Z is equal to 0. Okay, when Z is equal to 0, so we cannot consider Z is equal to 0, but the ROC of the signal is already its modulus of z greater than 1. So the combined result you can write like this: modulus of z greater than 1. So this is actually the transform x1 of z. Okay, this is actually x1 of z. Now we can write the second signal x2 of n. Okay, this is x2 of n, which is written by 2 by 3 the whole raised to n into u of n. And the transform of this particular signal based on this equation a raised to n into u of n, you can apply this particular equation. So it becomes z by z minus 2 by 3, and which is equal to x2 of z. And the ROC you can write modulus of z greater than 2 by 3 because it's a causal signal. So you can see that this is the point 2 by 3, and you need to construct a circle here, and the ROC is greater than this point. Okay, so we got another signal. Okay, and based on the convolution property, x1 of n convolution x2 of n can be written as x1 of z into x2 of z. Means simply you can write x1 x of z. Okay, x of z is equal to x1 of z into x2 of z. Okay, instead of calculating the transform of the entire signal, I can write like this. So it becomes z raised to minus 2 into z by z minus 1 into z by z minus 2 by 3. Okay, and the ROC you can see that one signal is greater than 1 and another signal is greater than 2 by 3. So both signal converge for modulus of z greater than 1. So I can write the final ROC like this: one point is here, one point is here, 2 by 3, and the both signal converge for modulus of z greater than 1. So ROC of the combined signal is modulus of z greater than 1. So here also you can write the ROC is modulus of z greater than 1, and after simplification you will get simply 1 divided by z minus z minus 1 into z minus 2 by 3, and the ROC is modulus of z greater than 1. Okay, next we'll discuss another question. Here again we need to use z transform, find the convolution of two sequences. If you compare with the previous question, it's different. In the previous question we need to find the z transform of a convoluted signal. Okay, now the question is different. We need to find the convolution, means the final result again we need in terms of for example if it is two signal x1 and x2, we need to find the convolution of these two signal x1 of n convolution, okay, x2 of n, and assume that the result is y of n. Okay, and in time domain we can perform this particular Okay, for that we need to use the formula, convolution formula. Okay, like this: sigma k is equal to minus infinity to infinity x1 of k into x2 of n minus k. In this way you can find out y of n, but instead of that we need to apply z transform. Means we need to take the transform of this particular equation. You need to find the z transform of this particular equation. So it becomes y of z is equal to x1 of z into x2 of z. By the convolution property you can like this. So first we need to find out the transform of x1 of n. So so this is the formula to find out the transform of a signal. It's a transform of a signal, because n is equal to minus infinity to infinity, x of n is raised to minus n. But in the question you can see that the sequence starting from this particular point. So this is the 0 index, this is 1, this is 2, and this is 3, and this is 4. So I can expand this equation, or I can find out x1 of z like this. Sigma n is equal to 0 to 4 x of n into z raised to minus n. So based on this, if you expand, you will get x of 0 into z raised to 0 plus x of 1 into z raised to minus 1 plus x of 2 into z raised to minus 2 plus etc. x of 4 into z raised to minus 4. So I can substitute here. Here x of 0 is 1, so 1 z 0 is 1 plus x of 1 is 2, 2 into z raised to minus 1, and x of 2 is minus 1, so minus z raised to minus 2, and the next term is 0, so I don't want to write here, and next term is plus 3 into z raised to minus 4. So we'll get x1 of z like this. Now I can write x2 of z. Okay, x2 of z becomes sigma n is equal to, I can check the index values. Here it is 0, this is 1, and this is 2, so it start only from 0 to 2. So I can write x of n into z raised to minus n. So if we expand this, you can write 1 plus 2 z raised to minus 1 minus z raised to minus 2. Okay, we got the two signals. Now we need to multiply these two signals, x1 of z into x2 of z. So if you multiply this signal, you need to multiply x1 of z and each term, and I will write the simplified version, the final answer. So it becomes 1 plus 4 z raised to minus 1 plus 2 z raised to minus 2 minus 4 z raised to minus 3 plus 4 z raised to minus 4 plus 6 z raised to minus 5 minus 3 z raised to minus 6. Okay, you can see that here it is z raised to minus 4, and here it is z raised to minus 2. So maximum you will get z raised to minus 6. And now you can see that we got y of z. This is y of z, but we need y of n. So we require this y of n. So I need to find out the inverse of y of z. Okay, that is y of n. But if you compare this particular equation, you can see that it's z raised to minus 1, z raised to minus 2, something like this. So I can write like this. It's something we can call it as y of 0 into z raised to 0 plus y of 1 into z raised to minus 1 plus 2 into, sorry, in general form it is y of 2 into z raised to minus 2 plus etc etc. Last you can see that it becomes y of 6 into z raised to minus 6. Okay, means y of z you can calculate. Okay, y of z you can calculate by using the formula sigma n is equal to minus infinity to infinity y of n into z raised to minus n. Okay, if we expand this particular equation, here you can see that there is no minus term, starting from 0. Okay, y of 0, z raised to 0 term, z raised to minus 1 term, z raised to minus 2, etc. up to z raised to minus 6. So you can directly compare these coefficients. So I can compare all these coefficient values. So this is y of 0, and this is y of 1, and this is y of 2, etc. So I can write y of n simply y of n is equal to, okay, is not a of z, is y of n is equal to, it becomes 1 4 2 minus 4 4 6 minus 3. Okay, so this is y of n. Okay, simply I can compare these two quantities. Again I will go to the question. Here we need to find the convolution of two sequence, means again we need the answer in terms of y of n or in time domain, not in z domain. But to calculate the convolution we need to use z transform, not the direct method. So direct method means we need to use this particular formula. So instead of using this particular formula, I will use the convolution property. Instead of using this, I can say that the transform is simply the product of 2, and when you do this you will get only in y of z, in terms of y of z, but we required y of n. To get y of n, we will take the inverse, or we will compare the transform equation with the given equation. So if you compare these two equations, you can see that this is the coefficients. You can compare the coefficient. From this you will get the idea that the signal is from starting from 0, 1 4 2 minus 4 4 6 and minus 3. And next I'll give a practice question similar to the previous one. You need to find the Z transform. Using Z transform, you need to find the convolution of two sequences. The two sequences given is of length 4 and here the length is 3, and the solution we will discuss in the next class.